right, here is your pre-calculus lesson for Friday, March 20th. So this is the assignment that I gave you yesterday, and here are the answers. So let's go over how we get this stuff, okay? So first of all, on the first one, we take the absolute value of -1/2, which is 1/2, and that's going to give us the amplitude. That is a vertical shrink since it's less than 1. So that basically means the curve's going to go from this to that height, okay? The period, we take 2 pi and divide it by b, which in this case was 2. And that's going to give us pi. So normally the length would be 2 pi, and now we're going to shrink it in half to just pi, okay? The negative right there is going to reflect it over the x-axis. So normally the sine curve looks like this, but it's going to, instead of going up first, it's going to go down first since it's negated. The phase shift is -c, so negative pi over b, which is 2. So that's going to give us a positive pi over 2, which means we're going to go to the right, pi over 2 units, okay? And since there is no number that's being added or subtracted either here in the end or in the front, there is no vertical shift. So what you're always going to do is start with the phase shift. So we start at pi over 2. Then you add pi to that because pi is the period. So 1/2 pi plus 1 pi gives us 1.5 pi, which we'll call 3 pi over 2. Then you're going to take the period, which is pi, and divide it into 4 parts. 4 parts because it's the quadrants. So first I like to divide it in half, and then each one of the halves in half. Then, since pi divided by 4 is pi fourths, you're going to take 1/2 and add 1/4, add 1/4, add 1/4, add 1/4 pi. And that's how you're going to get these numbers. Okay? Then on the y-axis, you're going to go up to 1/2 and -1/2 because of the amplitude. But instead of it starting at the origin, because it had the phase shift, it's going to start here, and then it's going to go down and then back up. And the overall features of a sine curve is it starts and stops, the period at an x-intercept, and halfway in between has an x-intercept. And then halfway in between x-intercepts, it'll have minimums and maximums. And it has the minimum first because, again, it's negative. Okay, let's look at the next one. So this one is a cosine curve, so that's why it's going to start at a maximum and end at a maximum. So you have to know what the basic cosine curve looks like. The amplitude is 3, because that's the vertical stretch. The period is 2 pi divided by 1/2, which is 4 pi. That is going to be a horizontal stretch. So instead of being a length of 2 pi, it gets stretched to 4 pi. There is no phase shift because there is no c, but this one does go down 2 units. So again, no c value, but it does have a d value. Okay, so this one, we start with the phase shift. Since there is none, we're going to start at the origin. Okay. Oops, I just realized this needs to go, oh, never mind. So normally, the ones in the yellow highlights, these are the 5 key points. So again, normally it starts at its maximum, at the end is at its maximum, halfway in between is at its minimum, and then halfway in between those, it's at its x-intercepts, which is the exact opposite of the cosine curve. Okay, so I plotted these 5 key points, and you always do that before you do the vertical shifting. So once you get those 5 key points, then you just move each one of those down 2 units. And that's how we get the new 5 key points, and then you just connect them with a nice smooth curve. Notice on both of these, all that I have graphed is 1 period. Okay, so the third problem, a little bit more complicated still. So we've got the amplitude is the absolute value of 1/3, which is 1/3. So that's a vertical shrink. The period is 2 pi divided by 2/3, which is going to be 3 pi. So that's a little bit of a horizontal stretch. And then the phase shift is negative pi over 2 divided by 2/3, which is 3 pi over 4, and since it's positive, it's going to the right. Okay, so notice that is the same sign as the direction, and that's because we already make the formula negative. All right, so this one again is complicated. Normally we would start at the origin, but we always do the phase shift first. So we start at 3 pi over 4. You're going to take that number and you're going to add the period, which is 3 pi. That's going to give you 15 pi over 4. So that's where you're starting and that's where you're ending. 1 period. Then again, we always divide it in fourths. We take the period and divide it in fourths because of the 4 quadrants. So that's going to give you 3 pi over 4, which is the distance between the x-coordinates of those 5 key points. And notice down here I did that fraction for you. So when you take 3/4 and add 3/4, you get 6/4, which is 3 pi over 2. I went ahead and simplified them up here. So again, divide it in half and then the halves in half. Okay? Then, since it's negative, it's going to start at its minimum, which is just going to be a negative 1/3. Very, very short little graph, but stretched out. And it's going to go, at the end, it's going to be at its minimum, halfway in between at its maximum, and then halfway in between those at x-intercepts. Okay? So let's move on to looking at some examples from your homework for Friday. Look at the notes there on how to do 1 through 10. For number 12, this is kind of what you're doing, is just finding the amplitude and period. You don't have to graph. 21 through 32, very similar to the ones we just did, but these don't have any phase shifts or vertical shifts, which makes them a little easier. And please do graph to scale. And what I mean by that, if you go back and look here, notice this one's real short. This one's longer. You should draw those to scale. Okay? Okay, the next one here, the directions say to graph from negative 2p to 2p, where p is the period. So essentially they want us to graph 4 periods of this curve. What you're going to do is you're going to graph 1 period and then you're going to continue it. So the first period is going to start at 0 because there is no phase shift. It's going to end at pi over 2 because that's the length of the period. It's going to start at its minimum and end at its minimum. Halfway in between will be at its maximum, and that's because, again, it gets reflected over the x-axis. So if we take pi over 2 and divide it in half, that's pi over 4. If we take that and divide it by 2, that's pi over 8. So there's 1 pi over 8, 2 pi over 8, 3 pi over 8. And then at the pi over 8 and 3 pi over 8, that's where we're going to have our x-intercepts. So again, you connect this with a nice smooth curve. And that's 1 period. So to graph the 4 periods, what we need to do is just continue that pattern. So there's 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, which would reduce to 3 pi over 4, and then 7 pi over 8. And we're going to do the exact same thing. We're going to do our 5 key points. Minimum, x-intercept, maximum, x-intercept, minimum, and connect with a nice smooth curve. And then we're going to do the same thing on this side. So again, we have minimum, x-intercept, maximum, x-intercept, minimum, x-intercept, maximum, x-intercept, minimum. And then again, we connect it with a nice smooth curve as best you can. Okay, and there's 4 periods of that function. Okay, the next one that we're going to look at, the graph has already been given to you. Okay, this is number 42. All right, so what you want to do is you want to find A, B, C, and D to plug them into kind of the generic formula, which is y equals A. This is definitely a cosine graph, unless you wanted it to be a sine graph that would have a horizontal shift. Well, it's easier just to make it a cosine graph. That way it doesn't have to have a horizontal shift. So A cosine bx plus c plus d. Okay. Doesn't look like there's any vertical shifting because it goes from -2 to 2. There is no horizontal shifting because it starts at its minimum. So that means that C and D are both 0. That's going to make it a little bit easier for us. Okay? Then if we notice the distance between one maximum to another maximum, that's going to give us our period. And since the period is 2 pi over b equals 2 pi, that means that b is just equal to 1. And since it started at its minimum instead of its maximum, it got negated over the x-axis, so it's going to be -2 cosine 1x, or just x. All right? Make sure you focus your efforts on being able to find the amplitude, period, phase shift, and vertical shift of the sine and cosine functions. Thanks, and have a great day.